This video will show you how to set up filters on Reddy. The example will be given on a data file recorded with a padded probe on a stainless steel sample with having a weld. As you can see in this data, we have a C-scan, the upper one for axial defect and the bottom one for transverse. The data file starts with a notch on the plane data file where I can see well the notch on the transverse C-scan. And then the scan is made on the weld itself. The weld produces a very strong signal that looks saturated in the color palette of the C-scan. The reason for this is because the nominal point is not maintained on the null mark. It's moving up because of the material properties change and liftoff variation. So if I move the cursor outside the weld, I can see that the nominal point is correctly placed. But on the weld itself, for both C-scan, there is movement in the lysagy. So if I want to see the defect that could be right in the weld, it's good to use a high-pass filter to remove this DC offset variation coming from the data. So one way of setting up a high-pass filter will be to, in the wizard ribbon, to select the process channel. In the process display, I have a choice between low pass and high pass. Here we want to set a high pass filter. Because the data was acquired with an encoder, both low pass and high pass are set in millimeters or inches if you're working in an imperial unit. So the size that you need to place is the cutoff of your filter. If, for example, I use the minimum, or not the minimum, but the suggested cutoff that I have here at 25 millimeter, that means the system will start to cut or to remove defects that are longer than 25 millimeter, and will keep the defects that are shorter than 25 millimeter. If I try with this value and I hit finish, the setup is generated. I need to rescan my plate or to reload my data file. So if I reload my data file, I can see the impact of having placed this high-pass filter. I will just change the scale of the display here. So the strong white color that was right in the middle of the scan before, where the weld is placed, is now centered on the null mark, and the signal looks much smaller, and I can detect the crack that are on top of the weld quite easily. Without such filter, it's very difficult to see the defect located in the weld. One thing that is important when you set filter is this value for the sizing, for the width of the filter. Normally you need to put the width of the filter, like the 25 millimeter, at least 3 times larger than the maximum flaw length you want to keep. So if you expect to have a notch up to 10 millimeter long, you will put your filter at 30 millimeter. 25 in this case was a good choice. Now let's look at another data file where it's a low pass filter that's going to be required. So I will change my project. I will open another inspection folder, and I will look at the corrosion probe data. So if I load the data file that I have in this folder, this is the results from a calibration plate on the far side defect on the aluminum sample. If I look in between the defect and I zoom a little bit more my signal, I can see that there is quite a lot of high frequency noise in this signal. I can say it's high frequency mainly when I select a small flaw, and when I look at this flaw and I see that the shape is not smooth and it's affected by those high frequency spikes. So one way to remove those high frequency oscillation is to use the low pass filter. So like for the high pass, I'm going into the wizard and I hit process. And now it's the low pass that I will set. Here again, the cutoff is in millimeters because the scan was encoded. If the scan was made on a clock, I would have to set the low pass in hertz. But right now it's in millimeters. And typically, this value represents which length of flaw will be kept in the scan. So if I put a value of 2 millimeter, for example, all the defects that are smaller than 2 millimeter, so and with a higher frequency, will be removed, and I will keep only the defect with higher or longer flaw, which represent to a lower frequency. So I will put 2 and hit finish. If I read my file again, I look at the same flaw here, and it looks much smoother than before. There might still some noise, and if I want, I can push the filter a bit more. But when I do that, I need to make sure that I will not attenuate the flaw response. So I can look at the voltage that I have right now. It's 0.43 volts. So normally when you set filter, you should not reduce the amplitude on your flaw. So that's the way of setting up filter. Just be careful that you don't reduce the signal size when you do that. The impact might be stronger on larger defect. So you need to be careful that all your flaws still size correctly when you set your filter value. That concludes this video.